just wanted to, I wasn't sure how much of the kind of basic ARA-crate stuff to do because I've presented to this group before and I wasn't sure whether people knew what it was, and I also can't see you all. Let me see if I can. Does everybody know what ARA-crate is to some extent? Why can't I?
No.
I'll say myself personally, I'm not very familiar. So
you don't. Okay, so I was actually. Sorry, I was assuming that we were starting from that base, and after conversations with Megan, I was going to move into a more advanced topic. So I'll give you the really basic stuff as quickly as I can, because there's some more interesting parts I want to talk about, but we'll see how far we get. So this presentation I've got here was delivered by Nick Teberger, who is one of the leads on the PARADISEC archive repository at a conference last week, the Digital Humanities Conference in Canberra. So I'll just use that to talk about ARA, because it's about ARA-crate, so I thought that was a contemporary thing I could talk about. To give you an idea of PARADISEC, it's got 30-something thousand records, which are sort of cultural collections, linguistics, musicology, anthropology from around the Pacific region. And we talked in this presentation about just to give you a little bit of background, PARADISEC is an archive that's been around for 20 years, which is pretty good as these things go for a small humanities project. And one of the key things that they did right from the beginning was to store all their data on a file server with metadata beside it. So they made up their own XML and they stored the data together with it. So Nick and I have been working together for several years. And from that kind of approach of PARADISEC storing data in commodity file storage, there used to be really only one kind of that, which was some kind of file store, but now we've got object storage as well, and possibly other things. From that came kind of articulating what PARADISEC did as a set of broader principles, the protocols for implementing long-term archival repository services, which we won't go to in huge detail here. But the aims of these, the technical aims are to make sure that data is not locked into any particular storage system, and to keep this idea that if you're storing stuff, you put the metadata with it. So all the metadata that you need is stored with the data. So the interesting one for this group is data is annotated. And so when we annotate things, we need some kind of vocabulary, right? What I mean by vocabulary and what this group means by vocabulary might be different. But I'm going to take vocabulary to mean all the stuff that we use when we're describing our data. So this is where we come to ARA-crate. So ARA-crate was designed with the design of ARA-crate came out of trying to do this thing, which PARADISEC has been doing for a long time, and which you need in lots of contexts for research data, where if you have a bunch of stuff sitting in a directory, or in a zip file, you need to be able to make, well, you don't need to, but it'd be really nice to be able to make a manifest that actually tells you what's in that file. And when I started working on this stuff 15 years ago, there was no obvious way to, given a zip file of data, we were working with environmental data from the Hawkesbury Institute at Western Sydney, with some scientists there. There was no way to do this. There was no kind of obvious standard for doing this. So that's how ARA-crate came about. So we want to come to ARA-crate. Okay, so what is ARA-crate? ARA-crate is a way, well, it started as a way of packaging research data by putting a JSON file. Does everybody know what JSON is? JavaScript Object Notation. So it's kind of a modern version of what people used to do with XML. You put, here's a little slide. So on the right-hand side of this slide, you have a fragment of JSON. So that's kind of human-readable, but this stuff is not meant to be, this is not designed for reading by humans. It's kind of probably at the level of intelligibility of XML. It's not something that you give to the users, but it's used inside the system. So this is a fragment of something describing a file. And on the right-hand side, that's just showing that we have stuff stored in a file system. So we have this thing, which is a .jpg, You can see what format it is. It's linked to the a vocabulary online, which is the National Archives in the UK, who have a really good set of formats. So that URI will resolve to their system and tell you probably which flavor of JPEG this thing has been identified as by the Siegfried software. So that's the core of RO-Crate, is that you describe stuff with JSON, and you put the JSON file beside the files. One of the nice features, the really nice features about RO-Crate, which stands for Research Object Crate, if I didn't say that, is that it strongly encourages you to also put an HTML file alongside the JSON file in the directory. So we can, if you bother to make the HTML file, and you can do that automatically, then you can actually provide some kind of view of what's in the inside the file. And it doesn't have to be just, you know, dog pictures. This could be the first few rows of a spreadsheet, or a graph, or something, you know, some useful visualization of what's inside the file. You can also give the file a name rather than just having these obscure file names that don't tell you anything. This is an example of that in action for a dictionary from the Central Desert, Arende language, which is blending a couple of things here. There's some images here, which are paintings done by a local artist. And there are a bunch of these dictionaries, which are from different languages from the region, which have stuff where you can hear people talking in language about these birds. And so that's just the same thing. It's just much nicer than the industrial looking preview with the dog picture in the previous slide. So that is something where Ben Foley, one of the people who works with us, made a little website that goes with the dictionary, and that's a completely static website, so it can be hosted with basically zero overhead. You just need a place to put it, sort of thing that can go onto GitHub pages. Contrasted with, these things were all originally a few years ago made as phone apps, and they lasted a couple of years before they stopped working altogether. So that's a real trap, locking your data up into something like that. RO-Crate allows you to describe the data and then to build this sort of thing automatically from the actual metadata. To show you things working at a different scale, this is a snapshot of the latest version of PARADISEC, which I mentioned before. This is all crates, but it's like tens of thousands of crates rather than just one, and it's all being delivered from a server. So these couple of screenshots here show RO-Crates driving a much larger archive. All the things in here are actually stored on object storage, and they're also backed up as a series of files and directories. So that's probably enough about to sort of give you a flavor for what RO-Crates are. Does anybody want to kind of ask any questions at this point, just to clarify before I move on? Okay, so to talk about the kinds of vocabulary. So all the things that inside RO-Crate I would consider of a vocabulary. If we look at the keys in this, on the right-hand side here, things like content size, date modified, description, those are all from schema.org. So that's a vocabulary. Does everybody know about schema.org? Assume you do in this context, right? So this is all schema.org. And then at some point you get, if you're dealing with language data, then schema.org doesn't cut it, right? So you need to move into some other terms. So when we're working I'm coming from the Language Data Commons of Australia. It's a project I'm working on, hence the link to PARADISEC and so on in the last thing. So we need to have some metadata which is more specific to language. So we do that actually. I'm just putting this into the browser here so you can see that we have a persistent identifier. And we have here still yet to be published as a pretty thing, but that persistent identifier resolves to this GitHub at the moment. So we have a list of terms. Can people see that all right? Should I make it bigger? Can see it? Okay. So things like dialogue, drama, formulaic, gesture, handwritten, these are all things that are from the linguistic domain. They're not in schema.org. So we have been maintaining this schema, which maybe gesture is a good one. So this is the vocabulary for describing language materials. And we have then something which Nick will know all about, which is a profile. So we have the W3 ID for this one. DAC profile. Whoops. What did I do wrong? Never mind. I'll start talking about profiles now. So that's that vocabulary that I just showed you is maintained and done in pretty much the same way as schema.org do their vocabulary. So that is a series of classes and properties which we define, basically following their practices, not trying to tie it into their organization. We're not doing the thing that bioschemas and some others have done where they are attempting to write stuff that then becomes part of schema.org. And frankly, that's just because that for a small project like ours, that looked like it was going to be too much trouble and like was not guaranteed to work. So we're just maintaining our own. We have a committee. We have a persistent identifier through the W3 ID scheme, and we do it that way. Right. So the other thing I wanted to cover today, just really quickly, is as people are coming, RO-Crate is getting increasingly popular. A lot of the things funded by the ARDC recently, the Australian Research Data Commons, they've just funded a bunch of things in the community data lab space, where I don't know the exact stats, but like more than half of the projects are using RO-Crate as a data interchange or data storage mechanism, and it's pretty widely used in the European scene for people implementing fair digital objects and getting European funding, mostly in the bio space, but it's pretty spread across the sciences. So one of the things that's a really hot topic for us at the moment is how do we define schemas like schema.org does, and then define profiles so that you can actually work with the data. So there's some notes here, which are kind of a set of requirements that we've been working on, defining terms like we're using schema rather than ontology. I think schema.org do this, and I think that was kind of partly a way of distancing themselves from the complexities that might come if you start talking about ontologies and people want to do reasoning and talk about representing the world too much, rather than just having systems that are kind of a bit more focused on practical metadata applications. So we've got this document, which I can send a link to, which the RO-Crate community has been talking about for a few months. And then from that, the latest development is that I've been working with the team, the broader RO-Crate team and the team at UQ on defining, moving beyond just the RO-Crate as a way, showed you it's pretty simple, have a JSON file and you describe some data. The next step is to define how we represent schemas and profiles in using RO-Crate compatible methods. So we've got this repository here. Again, I'll send you some links. And that shows work on what a profile looks like. So the idea here is that you can define this little diagram here. You can have we have an arrow crate, because we can eat our own dog food here, and we can use arrow crate to express the schema. You put an arrow crate JSON file inside this crate, and then from the schema, you can then generate a summary of the profile. So I'll show you one in a second. And you can also do validation. So you can take that metadata, that set of rules, you can take a candidate document, you can run a validator, and it will tell you whether this document complies with this profile. So this is at the stage of working, kind of proof of concept, and it looks like it'll be accepted as part of the arrow crate. I'll just show you what this looks like. I know I'm running out of time. So just really quickly, so this is one of the most used this is an arrow crate profile. There's an existing version of this, which was handwritten, and all of the rules for validating this are written in Shackle. But it has to be done by hand, right? There's no there was no link between them. And this is a demonstration of this profile here explains to you. So if we take something like the main workflow, so there's a main workflow entity in here. It tells you what properties it's supposed to have. Is it required? So you must have a programming language property. And then if this works, that doesn't work. And then there must also be a main there may be a main workflow diagram. Oh no, we must have a type. Anyway, it's still in development, but this is kind of basically the same sort of thing as schema.org has, where it tells you about the classes and properties and what's required for each one. So we're working on a way that you can have a single source and some English text that you combine together to get something you can use for validation and for generating the documentation, and also for running an editor, which I don't have time to show you, so you can actually use it to configure a metadata editor. And I know Nick is working in this space a lot as well, so and knows of this work, but I'd be really interested to get some feedback from Nick in particular at some point. So that's kind of my very quick tour of arrow crate and where we're at with vocabularies.
Shuffle my windows around. And I should be well under time, I would have thought. Yeah, this is not a long presentation. Okay, I'll emulate Pete and just do the presenter view thing here, because I will be opening up a couple other tabs just for a second. So yeah, just two things to talk about here, VocPub and VocSearch. And here's a little outline. Actually, I'll do it in reverse order, VocSearch first, then VocPub, a little bit of interplay. And I'll talk about the motivation. So the specific motivation for these two things was the International Data Week and then the eResearch conferences a few weeks ago. And so Rob Atkinson and I and others on the call were involved in some presentations there, mostly organized by Megan and Leslie, of course. And it struck me in some of the presentations there and work that I know is going on in the vocabularies community that there were a couple of things that I wasn't overly thrilled about, and I wanted to present a couple of approaches that differ from the approaches that have been taken elsewhere. So that's what this is a little bit about. Okay, so the first thing to present on is VocSearch. So VocSearch is an extremely simple application. It's just a multi-vocab. I'm almost reading off the slides here. It's a multi-source vocab search tool. It's browser-based, so it doesn't have a server or anything like that. It's just a web page that searches backends out there, different vocab backends, and it's free, and it always will be free, and all that sort of stuff. And the goal is to enhance term discovery and use. Now, this is the same goal that almost everybody in the vocab world has, including RVA, including international effort. So it's not like it's a new goal, but there's a couple of things that VocSearch is doing that are interesting. One is the low costness of it. It's just a little web page that one of my software engineers made, and I'll show it in a second. And it's able to be extremely simple and cheap because it makes a couple of assumptions about the vocab sources it's actually accessing. So as it says in the bottom left there, it's data model and access protocol dependent. This is not an all singing, all dancing, a magic piece of software. It's a pretty dumb piece of software. But what it does is it assumes that the sources that it's pointing at have a particular vocabulary model in their data backends. and that the way that the system can query them is driven by a particular protocol. So it uses the SKOS VocPub model, which we'll talk about in just a second, and the protocol, of course, is SPARQL, which is a graph search thing, which I'll talk about in a second as well. It can have adapters made for it to access, in some sense, any vocabulary system out there, including customized, specialized APIs like the RVA Open Search API, which is customized from this tool's point of view. It might be standard elsewhere, but from this tool's point of view, it's customized. So we can do that, but we haven't tried to do that. We've tried to avoid doing any work at all, really, because we're trying to demonstrate a thing which costs essentially nothing to maintain. It uses very little resourcing. You can make your own copy of it tomorrow, run it on your mobile phone if you really want. So let's have a look at it. Here it is here. It's very little, simple little search page. And if we search for something, let's just see what happens. So I'll search for the word coal. You could search for anything, really. I know there's a lot of resources about coal. So it's very quick. There you go. It's given us a bunch of responses already, and it's going and finding more. It's found 3 vocabularies that have got coal in them in some form, and it's using a little bit of assumptions about, you're looking in the title of vocabularies, you're looking in their descriptions and so on to find matches on the word coal. And then it's found 133 concepts with coal in them somehow, and it's told you which endpoints it's getting them from. So the vocabularies are our demo, which is our company endpoint, and then also the Geological Survey of Western Australia, which Angela, who's on the call, is from, and Geoscience Australia. No surprise that they would be including the word coal. And then the concepts, 133, and we can see here the vocab matches, here are the concept matches. It's very simple. And it is trying to make the point that search and so on like this can be simple. This is the whole purpose here. We can click on these things, we can find more information about them, we can go to the original resource, there's more information, the vocab it's from, etc., etc. So very basic stuff, but it's meant to be basic. That is the purpose. And one of the things it's showing off, apart from actually being a tool that we use, so we're starting a new piece of work for the Northern Territory Geological Survey right now, and part of the consulting work for them is to assist them in finding vocabs and reusing terms. So many of the vocabs here are vocab sources are other geological surveys which will be of interest to them. We want them to find and reuse terms there, so that they can, maximally reuse the definition for coal, etc. So we've made this tool so that we can actually day-to-day help them with finding terms, yay, but we're also trying to demonstrate that this can be extremely simple. It doesn't have to be a difficult task, which I've seen, I think, overcomplicated a few, sometimes in the community. Okay, so that's VocSearch, extremely simple, data model dependent. Great. Now to the second part. What's VocPub? So VocPub is a profile, as Pete's already mentioned. Profile, in this case, it's a set of rules about and conventions about how you would use the SKOS vocabulary data model. It basically mandates certain kinds of metadata and element structures. It says things like your vocab must have a title and it must have a created date, etc., etc. Very simple stuff, very much like the RO crates assumed metadata models. It's got a little bit of requirements to do with vocabulary structure. You can only have one concept scheme per vocabulary. This is not a process that everyone follows, but in this case, this is what this model requires. And it's used in many vocab catalogs. It's certainly used in all of the ones that I've just shown here. So the Geological Surveys of Western Australia, Indigenous Data Network, all the ones that we've been involved with, that's no surprise. But there are organisations overseas that use it, French Geological Survey, etc., etc., British Oceanographic Data Centre, they all use some variant of this, if not the exact model. It provides a validator. So just as Pete mentioned, if you know that you're using or someone's claiming to use the VocPub model, you can validate that. You can say, is it really VocPub valid? You can press a button and you can actually see that happen. And critically, it can be extended in a formulaic way, which goes to some way to answering that question about how do we manage all of these profiles. As Pete mentioned, it follows this profiles vocabulary mechanism to say, I've already got a profile of SKOS. I can make a profile of this for a certain purpose. So one example is Geoscience Australia. They have an enhanced version of VocPub, which just mandates a couple of extra requirements. So very simple extension, but it's there, and they apply that to their vocabs. And what that means is that their vocabs are both VocPub compliant and also SKOS compliant, and also meet the requirements for their internal purposes, like having catalog numbers and so on, that not everyone's concerned with. So I'll just click on the link and actually just show what this thing is, and then that'll be enough on this profile. So it's a written document. It's got a specification here, long and boring, and the specification's got a bunch of rules written in red. So each vocabulary must be presented in a single concept scheme, and they're all numbered. All concept instances within a concept scheme must be contained in a single term hierarchy. So very simple to articulate rules. There's validators that match it. And what we presented at eResearch was a poster that talked about where to from here for VocPub. So VocPub is now being used more broadly than just the original creators. So I created this thing in government many years ago, almost 10 years ago now. It's used a bit widely. It's certainly used by people who I'm not aware of, and it means that it's not possible for us to sort of fully own it and manage it. We have to be more caring and sharing community there. So we encourage the community and users to be in contact, let us know how they're using this thing, what they want from it, and we want to move to a more community governance model there. And it's, again, this doesn't solve all your problems regarding vocabs, but it certainly addresses conventional vocabs of a certain sort. Now onto the interplay. I've sort of mentioned a couple of these points, but the issue I see arising is that there have been many proposed vocab API and data exchange standards, not just one. And in the last little while at the International Data Week and so on, there's another one, the mod API, which I have no problems with. There's nothing wrong with the mod API. It's a sensible API for accessing vocabs, but it's not the only one. Some problems with vocab API systems in general is what is the scope of the vocabs we're talking about. The mod API is very much concerned with sophisticated vocabularies, ontologies and data models, not just simple classification vocab. So that's one thing to note. The functions that these initiatives are trying to address can vary, and the technology that they require or expect to use can vary too. So I've mentioned the mod API. So we've committed as a company to supporting the mod API in our products. We'll get to that in the early quarter of next year. But it can't be our primary data model or API because it's just not one for one with the things that we do. And my overall proposal is that almost all of the initiatives that I've seen regarding vocab exchange and use and federation and the ability to do things like make simple tools like VocSearch, they can actually be satisfied with really the SKOS data model and a couple of extra bits and the SPARQL protocol. So just a couple of notes about SKOS, which I'm sure most of you are familiar with. It probably does everything you ever wanted regarding classification or terminology vocabs. So if you want different labels, if you want ownership, if you want versioning, all of those things are known in the SKOS community. They may not be handled by the core SKOS model, but they certainly handled by the SKOS plus other conventional models. And that's why we've got the SKOS plus indicator here. So there are examples of, for instance, very sophisticated and very simple versioning mechanics out there in the community using SKOS. And at the moment, I'm making recommendations to some OGC community members and the ISO community members to use versioning of a certain sort that we have 10 years worth of evidence for in SKOS. So if you want to do classification vocabs, you want to do versioning, we've probably got a very good answer for you. So it does multiple labels and all that sort of stuff. So again, we don't need to reinvent these kinds of mechanics. They're there. SKOS, because of this ability to add other models in, will overmap and downscale to other kinds of models. So recently we had a discussion about the use of generic code, which is a tabular mechanism for describing terms. And the generic code model can be fully represented in SKOS quite happily. So, so if you want generic code, you could use SKOS and you could export to generic code. And just as an example of how sophisticated it can get, here's the stratigraphic chart, which many of you would be familiar with, and all of its lovely colors. And the entire content for this chart, which has for many years has been a PDF thing. This is an auto-generated web page that is drawing from a SKOS plus vocabulary. The hierarchy is a SKOS hierarchy. The numbers are SKOS elements plus ages. The colors are SKOS plus scheme.org's color field and then color values. So this is a SKOS plus vocabulary. It's pretty plus. It's got quite a few sort of extra things, but it's still a classification vocabulary. We can classify rocks by their age according to it. And it's still at heart a fairly straightforward vocabulary. And then last point here is that it can grow to accommodate more complex vocabulary. So if we have a specialized ontology or schema, as schema.org would call it, we can actually grow a SKOS vocabulary into becoming that thing by adding more classing and so on to it. And I'll just show one quick feature here, which is, this is searching for, actually I won't show this. This is a geological Servo WA's class hierarchy, so it's not a vocab, but it can be represented as a vocab. And then if you need it to be stepped up to being a full domain ontology, you can do that. But it's the last point that I'll make here. SPARQL. Okay, so that's about the SKOS model. It probably does what you want, and if it doesn't do it out of the box, and there's not a 10 years worth of community evidence as to how it does it, you can probably grow to using it. The next one is SPARQL. So SPARQL is not just a query language. It certainly is a query language, but it's also a communications protocol as well. So if you want to know how to send a query to something and how to get the response back and what format that response should take, that's all standardized in SPARQL. And that's really powerful. It means you don't have to invent an API to use SPARQL. It tells you how to do that. It includes data management as well, so adding and removing data, etc., through the graph store protocol. So it's a very comprehensive set of standards, actually, and it gives comprehensive data model coverage. What this means is if you've got your data in a semantic graph, whatever the form, whether it's a SKOS only vocab or a SKOS plus, you can access every part of that with SPARQL. You do not need to implement special endpoints or whatever. You can absolutely address every part of that through SPARQL queries. There's standard JSON outputs from SPARQL queries. So if what you want is, I want to get vocabs as flat lists of terms with descriptions in a JSON list, SPARQL can do all of that, and it's always been able to do it. So again, we don't really need to invent new mechanisms. We just need conventional ways of accessing data models. And the very last point.
Okay, one more minute, Nick.
Yeah, that I'll easily fit it in there. Okay, so what you see here is a query that I ran just before this meeting. It is accessing the OGC Rainbow set of definitions, and it's querying for a SKOS concept that is also an abstract concept. Now, I don't really know what an abstract concept is. Secretly, I do. But what this is showing is that we've got a standard SKOS vocab here, where the objects in the vocab have some other special kind of classing, some other special data model stuff going on. And these kinds of queries can access those things quite happily. And I could query for things that are just concepts, and I could query for special things. And if there were extra properties and extra classes, I could write queries for that too. So however sophisticated the vocabulary model, SPARQL will allow us to get there. So that's it. We don't need, I think, to have endless 5-year cycles of new APIs to access vocabs and things like that. We actually have a well-attested model that's extensible and has been designed to cover traditional and existing vocab models and future-proofing itself by an extension mechanism. And we have not just a query language, but protocols to access it. So my plug is you can invent tools like VocSearch and more sophisticated ones by using the technology and so on that we already have. We don't need to do something new. That's it. That's my presentation.